So today we discuss Gauss's law. Gauss's law. That's a very important in board exam class 12 and also the very important in NEET and JEE exam also. And what is Gauss's law? And before discussion of Gauss's law, we know that what is a flux phi. The flux equal to number of electric field causing a unit surface area. So E dot, if call a unit area, so there is a delta A, otherwise you can write only A. There's a closed surface integral, there's a closed surface integral, okay, there's a phi, and phi is a scalar quantity. So here we see that a surface, and this surface, the inside the surface there is a charge, either plus or minus, there is a charge plus q, and inside anywhere, not only that point, here say there is plus 2q charge, here say that a point plus 3q charge, or here is a suppose 0.5q charge. If someone say the plus here, the other is a minus charge here. So there is a charge inside that a surface, okay, and that phi, that is equal to a charge, okay. Here is the charge, the number of charge, there is a charge enclosed by that surface, and this is the enclosed by the surface, by the surface over epsilon naught, the permittivity of free space. That's the Gauss's law. And this surface, when you say that is a Gauss's law, and this surface is called Gaussian surface. Gaussian surface. Okay. So here, how to calculate the Gauss's law here? Suppose there is a charge, okay. Suppose there is a charge Q. If you want to calculate electric field at point P, now that's the very easiest way. So you draw a Gaussian surface, okay. This surface is a Gaussian surface, and say that the area, surface area is the A. And here the area vector, if I consider small area, suppose there is a small area A, or call it delta A in that direction. If plus q charge inside by the Gaussian surface, there is a plus q charge, so we know that electric field is outward direction. So E is the outward direction electric field. Okay, and that and here is the permittivity of free space, means there is a vacuum free space over here. So that phi, the Gauss's law, that is a charge enclosed by that Gaussian surface over epsilon naught. Okay, and they're very easy. If you consider surface charge density, so here phi equal to E dot dA, an angle between E and dA, if I consider the positive charge, so there is a plus flux, a positive flux, EdA integral closed surface integral, that is q over epsilon naught, if that is a E, and outside the integral, that is a dA, that is q over epsilon naught. So here EA times q over epsilon naught. What is A? A is the surface area. So enclose the surface, and this shape is a like a sphere, a 3D object, a sphere. So surface area of sphere is 4 pi r square, that is q enclosed, this q charge is enclosed by that Gaussian surface over epsilon naught. So E equal to q over 4 pi r square times epsilon naught. And we know that q over 4 pi r square, that is a sigma, the surface charge density. So finally we get E equal to sigma over epsilon naught. And if either E vectorically represent vectorically E, so the direction of E, and if I say that position is R, that is sigma over epsilon naught. Here is the R cap. That's the magnitude of E. That's the magnitude of E, and that is the direction. That's the Gauss's law, basic concept. Okay, and actually Gauss's law help to calculate electric field at any point in, if any point, okay, in any point in space. And how to calculate? So if I choose any point, now I choose a Gaussian surface, that surface or the line of the surface is passing through that point. Okay, and now we can calculate, and these surfaces enclose some charges here. Okay, that's the basic of Gauss's law. Gauss's law help or find to calculate, find to calculate E. That's the main application of Gauss's law. Okay, so if you want to more about the Gauss's law or application of the Gauss's law, so there is a lecture series or a full lecture or present in that YouTube channel. Okay, I put that link in I button if you want to see that lecture here. Okay, that's the 5 minutes of Gauss's law. Okay, thank you.